Greetings to all of my colleagues in Indonesia, and thank you so much for inviting me today to speak to you, even though we can't meet in person. My topic today is the careful use of artificial intelligence when learning physiology and medicine. So, artificial intelligence in physiology and medicine is making a huge difference in the way we approach both fields. There's a lot of good that can come from it, but there are also some precautions because we have to be careful to avoid the downfall of traps that artificial intelligence has created. So, in the good, it applies both to clinicians as well as to researchers because searching the literature now has become so much faster and easier. Artificial intelligence also can be leveraged to do a lot of work that would take humans a long time, such as evaluating large data sets, patient record collections, and imaging, where artificial intelligence has been shown to recognize patterns better than humans. On the other hand, artificial intelligence is only as good as the information it has been trained on. It is subject to making up information, what we would call hallucinations, and it cannot ever replace human interactions. And it will probably be a long time before we have robots that are able to give empathetic answers, truly empathetic answers. And then there's always what is now called the art of medicine. It is that intuitive intuitive reaction, that intuitive knowledge that an experienced clinician has that is not necessarily going to be factual that you could put into an artificial intelligence search engine. My example of this comes from my husband, who is a longtime general practitioner. And 1 year before the days of CT scans, he had a patient come in complaining of not feeling well. Her physical exam was normal, all of her blood values were normal, but he said he could look at her and tell that she was very, very ill. And sure enough, it took about 2 days, but she had an internal abscess that had been leaking toxins into her bloodstream and making her feel bad, but not enough to send her blood cell counts out of range. About 2 days later, the abscess did start leaking enough to activate her immune system, and they were able to find that and take her to surgery. But it was that intuition, that clinical intuition of the art of medicine that told my husband that she was ill before there were any factual findings. So I don't believe that artificial intelligence will ever be able to replace that aspect of medicine. So I have two sayings that I would like the students to remember as they go forward in using artificial intelligence. The first one is garbage in, garbage out. The second one is is trust but verify. So let's talk about them one at a time. Garbage in, garbage out is a saying that actually dates from the early days of computer science, meaning if your programming was awful, then the output that went with it would likewise be awful. So, where does that come with artificial intelligence? Well, AI programs can only synthesize the information that they have been trained on. So, if you don't train them on good information, what it's going to give back to you will be equally as bad. And so, if what is on the web or what you find in the scientific literature is incorrect, then artificial intelligence responses to queries will be equally incorrect. And I have a great example for you from osmolarity and tonicity. Some of you will have heard me speak on this topic before because it is one that students and even some teachers find very confusing. And to make it worse, many websites are wrong about osmolarity and tonicity. Here are some examples. The examples that I've used in the past, and I checked them today, and they're still wrong. So there's one website that says osmolarity is the concentration of solute in a solution per unit of solvent, which for us would be water. Well, that's wrong. It's per unit of solution. Tonicity, this same site says, is related to the number of particles found in solution. That's wrong. That's a definition of osmolarity, and it should be the concentration of particles found in solution. And finally, isotonic is denoting a solution having the same tonicity as another solution. Tonicity is a comparative term. You can't compare, you can't pick up a solution and say it has X tonicity. Again, that would be osmolarity. So all of these terms or definitions are wrong in this one website, but there's more. This is a website that says isotonic environments have the equimolar concentration of dissolved solutes. Once again, it's talking about osmolarity, not tonicity. The next two are even more concerning because this next one comes from a website called StatPearls that many American medical students use as the Bible, and they believe everything that's in it. But StatPearl says isotonic, hypertonic, and hypotonic compare the osmolarity of the cell to the osmolarity of the extracellular fluid. This is just wrong. Cells will always be in an osmotic equilibrium with the extracellular fluid. Where isotonic, hypertonic, and hypotonic come in is when you give someone an intravenous infusion and it tells you what happens to the cells. And then finally, one from Libre Text Medicine, another resource that our students here use frequently, says that the tonicity terms are all related to the osmolarity terms. And once again, they're totally incorrect. So, knowing that there was all this bad information about tonicity on the web, this morning I asked ChatGPT, please explain tonicity. And what came back was tonicity describes how a solution's solute concentration compares to another solution, usually the fluid inside a cell. Well, half of the frame of reference for tonicity is always a cell. And so that part is wrong. And it's also not the solute concentration. It is the concentration only of the non-penetrating solutes. And so close, but not quite right. And then the definition, Chat asked if I would like a table. So I got the table. And it repeats the same error. It says relative solute concentration outside the cell. But what I find even more concerning is this is from the second time I asked Chat to explain tonicity. I accidentally closed the window and had to re-enter the exact same prompt. On the first response I got, part of the definition had something at the beginning about non-penetrating solutes, but it didn't appear anywhere in the second answer. So even Chat doesn't know what to say when you ask it the same question twice. So there's our garbage in, garbage out example. Now let's look at trust but verify. Trust but verify means when you find something in an AI search, don't just take the word of it. and don't just assume that because it says there's a resource that's they're citing that it's accurate. I happen to like, rather than chat or any of the other search engines, I prefer the Google search because of many of the features that it has. So when I put into Google search, when is AI better than a human in medicine? The first thing that comes up is this clearly labeled AI overview. And the end of each of the paragraphs in the Google search AI overview, you'll see a link. And this link then tells you where the information came from, and you can click on it and it will take you to that resource. And you see at the right, it will give you two of the best resources. And so then below the AI overview, you will start to see resources, and many of them are from very excellent websites. This one happens to be from PubMed, which indexes many of the peer-reviewed journals in biomedical sciences. So if we look at PubMed, I hope you all know about it already, but it's a free resource. And the simple way to log into it is simply go pubmed.gov in your search box. And you can do a simple search here, just entering words, or you can actually do an advanced search. So I entered the title of that resource that was just looked at, and this is the page that comes up. You see the article and the title, where it is, the DOI number. But some of the features that I particularly like are the fact that if you click the cite button, it will give you the citation for the article that you can copy or download. And you can also choose the format if you want AMA format, NLM format, etc. In addition, if the authors have put in a pre-publication TypeScript copy, it will show up at PMC PubMed Central, and that will always be free for you to download. And then very often there will be a link to the original article. And many of these now, for more recent articles, are open access. And then finally, after you've read the abstract and looked at everything else, if you scroll down on that same page, you'll get a list of what the PubMed search has pulled up as similar articles. So there's a simple way then for you to get links to more related information, not depending on an artificial intelligence search engine. So you have to be careful. As we said, AI can make mistakes and hallucinate. And we have a recent example showing how these errors have crept into the peer-reviewed literature. And that example is the phrase vegetative electron microscopy. Well, there is no such thing. But a Google search yesterday came up, Google Scholar search yesterday came up with 26 papers that actually have the term included. Now, one has been corrected and one was retracted, but the others are out there in the peer-reviewed literature talking about the method called vegetative electron microscopy. So, where did it come from? Well, it was an AI error. What happened is in the 1950s, some of the older papers that were not made in digital days had been scanned and digitized. And so AI is actually able now to go and look at these scanned, digitized resources. And what happened is AI was not programmed to read two-column text. And so you can see highlighted in yellow, vegetative actually refers to something in the left column, but AI read it across as vegetative electron microscopy. And so it then ended up in the literature. The error was compounded because it turned out many of the papers are coming out of the Middle East, And in the Farsi written language, the words for vegetative and scanning differ by only a single dot. So here is a picture showing you the two words, vegetative electron microscopy on the top and scanning electron microscopy on the bottom. And you may not be able to see it, but the top word has two little dots underneath at the end, while the second word has only a single dot. So here's a translation error that has now been perpetuated into the peer-reviewed literature. So remember the two sayings for using artificial intelligence: garbage in, garbage out, and trust but verify. So use artificial intelligence wisely, but always remember that nothing is ever going to replace the human element in medicine. So thank you for having me speak today, and I hope that your study of physiology will make all of you who are students into better physicians. Thank you, and bye.